Hello everyone. So in this particular video, we are going to see the next question that is related to directional overcurrent relay and where it is basically used. So if I just say where it is used, basically it is used in parallel feeder. Uh, you will be having multiple parallel lines to protect the transmission lines. We basically you use this particular relay, directional overcurrent relay, that I will explain like how and why we use this particular directional overcurrent relay in parallel feeder. Okay, so let me take one example. Let's say you have this source and this is a transformer and you have two parallel feeders or parallel lines, you can say. Okay, and this is your load. The main difference in between directional relay and directional overcurrent relay, like if you see the just overcurrent relay, the relay will trip if the current is more than the pickup current, you can say, or the CT secondary current is more than the pickup current of the whatever the specified value the user has provided. That will depends on the pickup current. If the this relay current or city secondary current is more than the pickup current, then relay will operate. But in case of directional overcurrent relay, one extra thing comes into picture. First of all, the operating coil current must be more than the pickup current, you can say, and at the same time current should flow or power should flow in a particular direction, then only my relay will trip. If the power or current is not flowing in that particular direction, my relay will not operate. So it will have one directional unit also. Okay, now to protect these two transmission lines, we use the overcurrent relay and distance relays and all. But in this particular case, I'm not going to consider the distance relays and all. Just I will consider the overcurrent relay. And the overcurrent relays and all only depends on the pickup current magnitude. Okay. Now let's say you have these four relays placed, two relays placed towards the source side. This is A, B, and this is C and D. Two relays are placed towards the source side and two relays placed towards the load side. This is your load. Okay, and at normal condition the current direction is simply here. So this is how your current is flowing here and current is going to the load. Okay, so from source to load your current is flowing. Now uh, let me take four overcurrent relay, just normal overcurrent relays. So this is your C, this is your D. So basically we represent the overcurrent relay in two directional. Like it is a non-directional. So it can operate. It will just check the pickup the operating coil current IR. If it is more than the pickup current, that's enough for it. Like it will not detect in which direction the current is flowing and all. It doesn't even care about all of those things. Now let's say fault has occurred here. Okay. Now the current will start flowing through this fault point. This is my fault point and current will start flow like this and current will come like this. Okay. Basically I should draw like this. So for this line also some part of the current will come like this. Okay. So this is how your current will flow. Okay. Now because of this fault, my current that is flowing through the city secondary, or you can say current flowing through the operating coil is more than the pickup current. So my overcurrent relay will trip, and what will happen? Basically, your relay will start tripping. Now, what are the relays that will trip? That will I need to check. This current, this D relay will definitely trip. This not the relay will trip, but the relay will send the signal trip signal to circuit breaker. So this D relay will send the trip signal to circuit breaker. So this particular this section is gone. At the same time, current magnitude is high, and let's say this current the current flowing through this relay coil is also more than the pickup current. So this C relay will also send the trip signal to circuit breaker. So your entire line 2 will get simply be disconnected. Okay, and not only that, because if you see current was flowing through the line line 1 also, and we have this relay A and relay B. So fault current was also flowing through the line A and B also. So if the you can say the operating coil current is more than the pickup current, then relay B will also send the trip signal to the respective circuit breaker to trip that. So because of the fault, you are getting trip of this both the lines, both line 1 and line 2. But is it desirable? No, no, no. It is not at all desirable. We only want to trip that particular line that has fault associated with. So let's say I have one line, and let me have this is line 2. Okay. This is my relay A, relay B, relay A, relay B, relay C, and relay D. Okay. Now let me take the overcurrent relay or non-directional overcurrent relay in the source side, and the directional overcurrent relay at the load side. Okay, this is how basically we place the directional overcurrent. So this is the directional overcurrent relay, and these directions are simply representing if your fault current start flowing in this direction, then only I will send the trip signal to circuit breaker. Okay, now let's say fault has occurred here. Now we'll see the fault current. This is how fault current will come, and this is how your fault current will. Okay, if you see for relay D, initially at healthy condition, current was flowing in this direction, but because of fault, current started flowing in this direction. And this direction, the current direction, or you can say the direction of the power flow, is exactly matching with the direction that we have decided for the relay D. So because of fault, if the fault current, because of the fault current, the operating coil current is more than the pickup current, and also my direction also got matched. So this relay D will send the trip signal to circuit breaker, and it will get trip. And at the same time, for the C relay, you can say uh, my current also has exceeded the pickup current. So this C relay will send the trip signal to circuit breaker. Okay, and this A and C relay doesn't care about the direction, just only care about the magnitude of the fault current, you can say, or magnitude of the current. If even the for A and C relay, direction of the current in the healthy condition and the faulty condition, in both the condition, the direction of the current is same. So there is no question to put the directional relay at the source side. Is it clear to you? Let me explain you one more time. See, because of the fault, your current is flowing this direction and this direction. If you see the healthy condition also, in healthy condition also the current was flowing in this direction and in this direction. So during the fault and before the fault, like during healthy condition and during fault condition, your current direction is same. So there is no question to put the directional overcurrent relay at the source side, because the directional overcurrent relay will be costly. So we don't want to waste that amount actually here. So we will not put any directional overcurrent relay. Just we'll put just non-directional overcurrent relay. That's it. So now let me explain you. So we got that point, like here the direction of the current flow or direction of power flow is exactly matching that we have decided for relay D. So it will send the trip signal to circuit breaker, and this C relay will also trip because it is a non-directional overcurrent relay, and the current is exceeded the pickup current. So my line 2 will simply trip. But if you see the relay B, the direction of the fault current and direction that we have given to the relay B, it is reverse. Although my fault current has increased, and you can say the pickup or the operating coil current has increased, and it is more than the pickup current. But again, since it is a directional overcurrent relay, it should satisfy two things. First of all, the operating coil current should be more than the pickup current, and also the current flow must be in the direction that we have given. See, the direction that we have given is in this direction, right? In this direction. But my fault current is flowing simply in this direction. So direction is not matching. So my B, you can say the B relay will not send trip signal to circuit breaker. And that's how your transmission line 1 will not trip, and basically your faulty line will simply get disconnected from the system, but your healthy line will still deliver the power. So that's how we want, like we want your healthy phase should be connected, and your like unhealthy phase or your unhealthy line, that line that are associated with the fault, that should be disconnected from the system, such that we can maintain the, you can say, this particular case or this particular arrangement also contribute toward the stability issues, because if you suddenly disconnect the load, it can lead to the instability issue, the frequency instability issues, all of the issues can rise. So this is how, by having directional and non-directional overcurrent relay, we can operate our power system networks and all. Okay, and we use the non-directional overcurrent relay towards the source side, and we use the directional overcurrent relay towards the load side. Okay, I hope it is clear. But still, if you have any doubt, you can ask me in the chat box. Thank you.